Alright, so now we're going to finish up section 1.1 by looking at a few examples. We're going to look at evaluating functions, piecewise functions, and the difference quotient. So first, what does it mean to evaluate a function? Well, all that's telling you to do, if you see those directions, is we are going to substitute into the function for x, or we can think of it as the input, because remember, it doesn't always have to be x. So if I look here, I have a function h of x equals x squared minus 2x plus 3. I want to find what is h of 3, what is h of negative 4, and what is h of x minus 1. So I want you to take a minute here and try to do A, B, and C. So pause the video and evaluate what is h of 3, what is h of negative 4, and what is h of x minus 1. And then we'll come back and look if you got it correct. Okay, so for h of 3, we substitute in 3 for, in this case, x into the function. So we get 3 squared minus 2 times 3 plus 3. 3 squared is 9. 2 times 3 is 6. So 9 minus 6 plus 3, we get 6. So h of 3 equals 6. Great, we got an answer. We also want to understand, what does that actually mean? So again, you know, a lot of what we're going to do throughout this year is try to get a better understanding of, okay, great, I can solve this problem, I can get my answer, but I'm not done. I want to actually have an understanding of what does that tell me. So what does that mean? Well, it means that on this function, h of x equals x squared minus 2x plus 3, this is a point on that function. The point is going to be 3 comma 6. So the point 36 exists on the function h of x. For h of negative 4, we're going to do the same thing. Substitute in negative 4 squared minus 2 times the quantity negative 4 plus 3. Again, just be careful that we're substituting in a negative, so we want to put it into parentheses so we understand, in this case, when we're squaring it, that we're going to be squaring the negative. So it becomes positive 16, positive 8, positive 3, add those together. H of negative 4 equals 27. Again, this tells us the point negative 4, 27 exists on h of x. And then lastly, for h of x minus 1, now we're going to substitute in the quantity x minus 1 wherever there was an x. So we have x minus 1 squared minus 2 times the quantity x minus 1 plus 3. Multiply out x minus 1 squared, we get x squared minus 2x plus 1, and then distribute the negative 2, so I have minus 2x plus 2, and then plus 3, combine like terms, and I end up with h of x minus 1 equals x squared minus 4x plus 6. So now let's talk about what does this mean in this case. So clearly we didn't get just a number here, we got a new function. We have this h of x minus 1 function. Well, if we understand our transformations, which is going to be unit 1.3, but it's something that you've seen in the past as well, this x minus 1 here is telling me that I'm shifting 1 unit to the right. So h of x minus 1 equals x squared minus 4x plus 6 is a horizontal shift of 1 unit to the right. What that means is if I graph this parabola x squared minus 4x plus 6, and I graph the initial function h of x equals x squared minus 2x plus 3, they're going to be the exact same parabola, except for this is going to be shifted 1 to the right. Now another thing I want to point out is you can see down here, we want to really make sure we understand this function notation. So h of x minus 1 is not the same thing as h of x minus h of 1. I'm not going to take the time right now to prove that to you. You can prove that to yourself if you want by figuring out what is h of 1 and subtracting it from h of x and seeing that it is not the same thing. Okay, next thing we're going to talk about are piecewise functions. So piecewise functions are a function defined by two or more equations over a specified domain. Okay, well, what does that mean? Well, if we look at this example here, that we have f of x equals the absolute value of x minus 3 when x is greater than 1, negative x minus 5 when x is between negative 2 and 1 inclusive, and the quantity x plus 5 squared when x is less than negative 2. So here I have three equations, each with a specified domain. So now I want you to take a minute and I want you to evaluate this function at negative 7, at 1, and at 3, and I want you to try and graph the function. So pause the video and do that, and then we'll come back and check your answers. Okay, so hopefully you got f of negative 7 equals 4, f of 1 equals negative 6, f of 3 equals 0. And now real quick, if you didn't, let's check on why. So if I want to find what is f of negative 7, I'm looking at when x is negative 7. So which one of these domains includes x is negative 7? Well, it's this right here, x is less than negative 2. So I plug in negative 7 into this piece of the function. Negative 7 plus 5 gives me negative 2. Negative 2 squared is 4. So I know f of negative 7 is 4. Now here for b, f of 1. So which one of these includes x is 1? Well, that's the middle piece right here because it is inclusive for 1. So I plug in 1, negative 1 minus 5 is negative 6. And then when for f of 3, which piece includes x is 3, that's going to be this piece here, which is x is greater than 1. So I plug in 3, 3 minus 3 is 0, the absolute value of 0 is 0. Now I want to graph each one of these pieces, or basically, what I'm doing is I'm graphing the entire function, splitting it up into the three pieces. So when I do that, I'm going to start at each one's restricted domain. So for this parabola, or the quadratic portion here, or piece, I'm going to start at negative 2 and then work my way left because I'm including all of the x values to the left of negative 2. So at negative 2, it has a value of 9. That's going to be an open circle though because I'm not actually including that point, but that's still where I start. And then I work my way left. At negative 3 I'm at 4, at negative 4 I'm at 1, negative 5 I'm at 0, and then I can use symmetry to find the rest of the parabola. Then I'm going to start at negative 2 and I'm going to go to positive 1. So if I plug in negative 2 into this line, I end up with negative 3. I know it has a slope of negative 1, and at 1 I'm at negative 6, so I get the line. Those are going to be closed circles at the end because those are inclusive in that domain. Now I move on to the absolute value, starting at 1, even though 1 is not included. So if I plug in 1, 1 minus 3 is negative 2. The absolute value of negative 2 is positive 2. So I start at the point 1, 2 with an open circle, and then I'm going to draw my absolute value equation. If I want to plug in some other specific points, I can, or I can just understand that it has that V shape. Okay. So now the last thing I want you to do, again, pause the video here in a second and figure out what is the domain and the range of this function. So go ahead and pause the video and then we'll come. Okay, hopefully you got that the domain is all real numbers, or negative infinity to infinity, and the range is negative 6 to negative 3, including negative 6 and negative 3, and then 0 to infinity, including the 0, and then not including the infinity because we don't include that. That's not an actual number that we can attain. Just to quickly go over, well, how do we get that if we got the wrong answer? Well, x is less than negative 2 tells me that I'm going to start at negative infinity. So it's going everything to the left. Now I can also see that from the graph here. Although this arrow is pointing up, it's also going to continue to go to the left forever. So that's going to be negative infinity. This piece then goes up to, but not including negative 2. However, then the graph does include negative 2 down here. So although these are separate pieces, the domain is continuous. And then this is continuous up until 1, including 1, and it jumps up to this piece that does not include 1, but includes everything up to 1 from the right, and then this goes off to positive infinity. So that's how we get the domain as all real numbers, or negative infinity to infinity. Now for the range, we start at the lowest y value. The lowest y value is -6, including -6, and then this piece moves up to -3, including -3. Now here, there's a gap. So there are no pieces of the function that include y values from -3 to 0. But then at 0, both the absolute value and the parabola have a y value of 0. And then both of these pieces go up to infinity in the y direction. So that's how we end up with -6 to -3, including, and 0 to infinity, including 0 to 9, including infinity. Alright, our last example is a difference quotient example. So without getting into too much detail about this, the difference quotient is going to be very, very important. Spoiler alert, second semester, this is going to directly relate to the limit definition of a derivative. For now, we just want to get comfortable using it and understanding how to use it and simplify from it. So all we're doing is evaluating a function at f of x plus h, subtracting the function, and then dividing by h and simplifying. So we don't want to get confused by this f of x plus h. That's just saying evaluate at x plus h. Very similar to what we did 2 examples ago when we wanted to evaluate at h of x minus 1. Okay, so I want you to take a minute and try to figure out the difference quotient and simplify for f of x equals x squared minus 3x plus 1. So pause the video and do that. Okay, so again, first we want to make sure we want to understand what is f of x plus h. So f of x plus h is going to be x plus h squared minus 3 times x plus h plus 1. Okay, so that's the f of x plus h part. So now let's put this all together using the difference quotient. So I'm going to have x plus h squared minus 3 times x plus h plus 1, and then minus x squared minus 3x plus 1. So that's f of x, all divided by h. And now I also need to carry through this restriction that h cannot equal 0 because I cannot divide by 0. Okay, now we're going to expand, combine like terms, and simplify. So x plus h quantity squared becomes x squared plus 2xh plus h squared squared, and then I have minus 3x minus 3h plus 1 minus x squared plus 3x minus 1 all divided by h. H still doesn't equal 0. Now if we do this correctly, everything that doesn't have an h should cancel. And we're left with 2xh plus h squared minus 3h all over h. H still does not equal 0. Factor out an h, so I end up with h times 2x plus h minus 3 over h. H does not equal 0. The h's go away, and my answer is 2x plus h minus 3 h does not equal 0. Again, this will mean more to us once we start doing calculus. However, for now, it's a practice of how to evaluate the difference quotient. Okay, so just to kind of conclude, domain, the input or x values from left to right, we read them. Range is the output or y values, we read those from bottom to top. A function is a relation with only one output for every input. And when we say evaluate, we mean plug in and input into the function.